So we are done with the superposition theorem and the source of transformation. So we are now having our thevenins theorem as a method of solving the problem. So thevenins theorem. So step 1, open circuit RL and solve the voltage across the open circuited terminal. So applying KVL, so we have 24 minus ITH 0.2 plus 0.3. So this is based on the um, new created diagram. Minus 26 is equal to 0. So simplify 24 minus 0.5 ITH minus 26 is equal to 0. So 0.5 equal to 2. Then divide both sides by 0.5. Cancel out. Then our ITH is equal to 4 ampere. Mark as partial. So solve for VTH is equal to 26 minus ITH times 0.3 will be equal to 26 minus 4 times 0.3 will equal to 6 over 25 and 124 over 5 volts. And the next thing to do is step 2, compute RO, short circuit all the independent voltage. It's like this one, our source. So short circuit all the independent voltage sources and open circuit all the independent sources. So we can now solve our RO. So RO is can be solved by formula RA plus RB over RA plus RB. So simply substitute the given 0.2 times 0.3 over 0.2 plus 0.3, so it will answer 3 over 25 ohms. So we are done with our step 1, step 2, and we are now with our step 3, which is construct the thevenins equivalent circuit and solve the following. So I redraw the diagram into this one so that it will be easy for me to solve the IL. So IL, so let us first write the given. So 124 over um 5 volts, which is this one, our EO. So we can now have our IL, so by EO over RO plus RL, which is equal to 124 over 5. So IL is equal to 124 over 5 and 3 over 25 plus 0.5. So IL is 40 ampere. This one. So we have now our IL, so we can now directly solve our VL. So VL is IL times RL. So our IL is 40 times RL is 0.5. So we have our 20 volts for IL. So we can directly solve also for PL. IL squared RL. So it will have the result of 40 squared 0.5 800 watts. So we have now our IL, VL, and PL. So we are now going to solve our IA. So in solving RA, we have to redraw the diagram again. So we can now have, we open the R1, our R1 or RA is, we open it. So we have now our IT to solve for IT is 26 over 0.3 plus 0.5. So it will have 65 over 2. So we know that IT is equal to VB. This is the formula in getting IT. RO plus RB or RL. So that is why we got this one. So we have formula for solving IT2. And one is VB over RB. So we are now going to apply this. So we have 65 over 2 is equal to 26 minus VB over 0.3. So cross multiply, we have now 0.3 times 65 over 2 is equal to 26 minus VB. So 9.75 is equal to 26 minus VB. So transpose BB is equal to 26 minus 9.75. So it will have 16.25 volts. This is our VB. So we can now have, so we are done solving with our VB. So we have now to solve our RO for the next one. So I have here a diagram, so and the formula. So we can now have just simply substitute the given value. So 0.3 is our RB times 0.5, then 0.3 plus 0.5. So it will result 3 over 16 ohms. So we get our VB and our RO or our RN. It is same. So we can now use them to apply in solving IA. So I redraw the diagram using this given. So we have now a new way of solving. So we can now solve IA. So IA is can be taken as EO RO plus RA. So simply substitute 16.25 is our EO or the VV. So we can have 3 over 16 as our RO plus 0.2. So directly solve in a calculator, we have 20 ampere hour IA. So this is our RA. So since we get our RA, we can now get our PA. So IA squared times RA. So directly substitute the given times squared 0.2. It will have 80. It's 20 squared times 0.2 is 80 watts. So this is our PA. Then solve for IB. Solve for IB using key PL. IA plus IB minus IL is equal to 0. So basic algebra IL. So substitute negative 20 plus 40 is positive 20 ampere. So this is our IB. So since we get our IB, we can now solve our PB equal to IB squared RB. Then we have 20 squared times 0.3. So this is our PB. Power for our resistance, letter B. So that is all for thevenins theorem.